Question 6. Which of the following species is paramagnetic? So something that's paramagnetic has unpaired electrons, and it will actually be weakly attracted by a magnetic field. This is in contrast to a diamagnetic species, which only has paired electrons and will be weakly repelled. So we just have to go through these answer choices and figure out which of these has unpaired electrons. And we'll start with zinc 2+, right? So we'll just draw an energy diagram with orbitals. So this is going to be increasing energy. And of course, this zinc is going to be in this period here, right? And argon is going to be the noble gas right behind it, okay? And so with zinc, we'll start with 4s, and then we know that there's also going to be 5 3d orbitals. So this is going to be 3d. This is 4s. And we're just going to start filling the orbitals, right, one by one. So 1, 2, 3, 4, 5, 6, 7. So that's 1, 2, 3, 4, 5, 6, 7. That's manganese. We're going to keep going, right? We're going to go like this. That's going to be iron, cobalt, and then nickel, copper, zinc is going to be like this. Now this is zinc 2+, so we need to remove the highest, 2 of the highest energy electrons, which remember when we're removing them, it's actually going to come from 4s for these transition metals, okay? And notice that we've removed the 2 4s electrons, but still all the electrons are paired, right? So this is not going to be paramagnetic. It will be diamagnetic. Then let's do calcium. Okay, so I'll get rid of these electrons. Calcium is in the same period, and it's actually just here. It's an alkaline earth metal, so we just fill the 4s like that. And again, this has only paired electrons, and so therefore this is going to be diamagnetic as well. And then we have copper 1+. So let's get up to copper, right? 1, 2, 3, 4, 5. So that's going to be 1, 2, 3, 4, 5. And then we're going to keep filling these. That's iron, okay? And then cobalt. Okay, and then nickel. Okay, and then we get to copper. Now, what happens, right? Oh, sorry, this would actually be copper, right? Because this would be 1, 2, how many electrons? This is going to be 9 and 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? Now remember, this is one of those elements that has an anomalous configuration where once you get up to copper like this, this electron actually jumps up here because this is actually more stable, right? This is more stable because it will actually fill the 3D orbital, the 3D shell rather, with all the orbitals, and that actually imparts stability, plus it relieves this 4s repulsion, right? So this is neutral copper, but this is copper 1+, so we need to remove an electron. And where does that electron come from? Well, it comes from 4s. So once again, with copper 1+ specifically, right, neutral copper would actually be paramagnetic, but this is copper 1+, so we remove this unpaired electron, and now we only have paired electrons. So this is actually diamagnetic. So we're left with manganate, right? So let's actually look what manganate would look like, specifically 2+, the 2+ oxidation state. So we're going to start with copper. Again, we're just going to start filling these, and then up to 1, 2, 3. That's going to be 1, 2, 3, and then chromium. Okay, and remember that what happens at chromium is that ultimately this is going to jump up here so that we have an half-filled 3D orbital. And then when we get to manganese, we're going to fill this one again, right? And manganese, okay, well, already as manganese itself, it's actually paramagnetic, but we need to remove 2 electrons. So we're going to remove these 2, okay, because they're from the 4s. And voila, we get manganate, right, 2+. And notice that this doesn't have any paired electrons. They're all unpaired. So this is definitely paramagnetic, and D is the right answer.